So how did you attack the roughing on the second side?
Well, so the second side was basically, it had a big chunk of material out here, right? So we wiped that off with one big OptiRough toolpath. And then we had what I think is actually one of the coolest toolpaths on this whole part was for the second setup, I hit this with one unified multi-axis toolpath as a semi-finish to basically leave 10 thousandths of material on everything, which really set me up for finishing. And that was with a clean core style toolpath. Are you familiar with clean core toolpaths?
Yeah, so that's basically when you have a simple surface that doesn't have all these contours to it. Right. So that way you can always point your tool normal to that, and then you just retract it out to the part, right?
Yep, exactly. So it's a way of, taking all the complexity out of this geometry, just getting clean tool motion, and then using our Z-axis of our machine to create the actual profiles. So if we look at the screen here, this is me putting a unified toolpath directly onto the finished part. If I run an analyze toolpath on this, you can see there's a lot of tool motion, right? Like I don't need to be doing all this crazy tilting, because in this case the tool is just trying to stay normal to the drive surface. So what we need to do is create a clean core underneath it. So what I did was basically create some wireframe curves here, and this was just me manually just trying to trace the profile of this part out. If I just do a lofted surface, you can basically pick all 8 of these chains and pick this one twice. It will create this full loop of a surface body. And now this could be our clean core drive surface. Let's move this to another level so we can check it out though.
Now are those all splines?
So these are all splines, yeah. So I essentially just kind of went to a couple different angles of the part and just manually traced it. I could have projected them to it, but really I didn't want to project and get all this detail, right? The whole point of this is simplification. So I just manually made a spline that kind of followed the profile. But that actually caused a problem for me because all those splines, you can see, they don't meet perfectly tangent. So that creates this really weird wrinkle effect up where all the splines meet. You can kind of see, this would probably work, but we're going to have some strange tool axis motion that's going to show at the machine. So we need to clean this up. We can't really smooth the surface. We don't have like a smooth surface tool in Mastercam. I don't even know if something like that exists, but what we do have is mesh tools. So again, we mentioned earlier all the power that Mastercam has in mesh. This is a huge reason where I think anybody who uses Mastercam on any real world parts could use mesh in this way. So basically what I'm going to do is create a mesh from that clean core. I'll delete the old surface. So now this body is a mesh. This is no longer a surface, right? We have some mesh smoothing tools. So the first thing I'm going to do to interact with the mesh is just run check. Just make sure it's a clean mesh. It has some problems. It has some round points, it says, so let's just delete those. Right, so we kind of clean up the mesh a little bit. I'm also going to run a refine just to make sure all these facets are the same size. You can kind of see right now the facets vary in size. I like to make those a little more constant. So let's just run a quick refine on that. So now you can see they're a little bit more uniform, all pretty equal triangles. Next, you can kind of see these black lines here. Those are signifying sharp corners in the mesh. So there's still something strange going on there. What we can do is go mesh and modify mesh facets, repair. And I just want to repair this area, which is essentially going to delete those facets and heal the mesh over the top of it. Right, so there's that. All those problem areas are gone.
Wow.
And then finally, we'll just hit this with one big generic smooth. Right, we'll just kind of make sure this thing is nice and even. Just run that smooth. And just for the sake of seeing this better, let's clear that blue color off. There we go. So now this is a perfectly smooth mesh body. This is exactly what I wanted my surface to look like, but there's no way to get there with the surface. So from here, I'll just take this original toolpath, right, that I drove the tool against, and instead we're going to apply the drive surface as this mesh body instead of the final helmet body. I'll set this to run as automatic just because I just want to collapse in from the outside. And then the final thing I have to do is say retract my tool along its axis anytime that it collides with the real body. So I want to retract over those. Okay, great. And now when this toolpath generates, we'll see a really nice single flowing semi-finished toolpath. Now if I go analyze this toolpath, you'll see the motion is much more uniform. We're just using the Z-axis, we're using the tool's axis to approach and retract from that part geometry. And because I created some geometry where it goes over the face mask, we're able to get this whole part in one single toolpath. Wow. Of course, the step over here is a little bigger than what we used in the real world, but essentially, this thing is going to work perfectly. So I think you might find some use for meshes in your next part.
Oh, definitely.
Yeah, meshes are really cool. I really recommend you use them. And again, Mastercam has so many cool tools. I think it makes mesh a really viable way to make real parts.